Hi everyone, welcome to our physics class. In the previous class, we have studied about acceleration and different types of acceleration. So, what is the meaning of positive acceleration of a particle? The positive acceleration of a particle is defined as the rate of increase in its velocity. Negative acceleration of a particle or retardation or deceleration of a particle is defined as the rate of decrease in its velocity. Suppose if a particle moving with constant velocity, so what is the acceleration of a particle? Its acceleration is zero. When a particle moving with constant velocity, its acceleration is zero. So acceleration is a vector physical quantity and its SI unit is meter per second square. Okay, acceleration can be positive or negative or zero. So when a particle is said to be moving with uniform acceleration, if its velocity changes by equal amounts in equal intervals of time. So when a particle is said to be moving with non-uniform acceleration, if its velocity changes by unequal amounts in equal intervals of time or equal amounts in unequal intervals of time or unequal amounts in unequal intervals of time. So what is the meaning of average acceleration? Average acceleration is the ratio of change in velocity to the change in time. And what is the meaning of instantaneous acceleration? Acceleration of a particle at any instant of time. So the mathematical expression is A is equal to dv divided by dt. So after that, we have studied xt graph, right? So this is motion along a straight line, part 6. Okay, well, let's start today's class. So in this class, we are going to discuss about the velocity time graph. Velocity time graph means a graph drawn by taking velocity along y-axis and time along x-axis. Okay. The first graph, that is a particle moving with a constant velocity or uniform velocity. First, let us consider a velocity time graph. So what is the meaning of velocity time graph? A graph drawn by taking velocity, that is along y-axis, and time, that is taken along x-axis. The velocity is measured in terms of meter per second. Time is measured in terms of second. So after that, let us choose the scale. So x-axis, let us consider 1 unit, that is equal to 1 second. Okay, so 1 unit is equal to 1 second. What is this? 2, this one is 3, 4, 5, and so on, right? And in y-axis, let us consider 1 unit is equal to 1 meter per second. So this is 1, is this 2, 3, and so on. Okay, so a particle moving with constant velocity. Actually, here particle moving with a constant velocity, that is exactly equal to 2 meter per second. Okay, for example, a particle moving with velocity, constant velocity 2 meter per second. That means at time t is equal to 0 second. What is the velocity of the particle? Velocity of the particle is 2 meter per second. And at time t is equal to 1 second, what is the velocity of the particle? It is moving with constant velocity. Means velocity does not vary. Okay, that is v is equal to again 2 meter per second. At time t is equal to 2 second, what is the velocity of the particle? That is same. V is equal to 2 meter per second. Okay, at time t is equal to 0 second, the velocity is 2 meter per second. So what is the point in the graph? That is 0 comma 2. So this is 0 comma 2 point. That means in x-axis the value is 0, in y-axis the value is 2, right? And in 1 second, what is the velocity? Velocity is same, 2 meter per second. In the graph, what is the point? That is 1 comma 2. So this is 1 comma 2. That means along x-axis the value is 1, along y-axis the value is 2. Okay, after 1 second, that means at time t is equal to 2 second, the velocity is constant again, that is 2 meter per second. So this is actually 2 comma 2. Along x-axis the value is 2, along y-axis the value is constant, that is 2. After 1 second, the velocity that will remains constant, that is 2 meter per second, but time is 3. So this is 3 comma 2 point. What is this? 3 comma 2. And then after 1 second, the velocity that will remain same, that is 2 meter per second. So actually this is 4 comma 2, right? So now join all these points. So this is a straight line parallel to time axis. So this graph clearly shows what? A particle moving with constant velocity or uniform velocity. Constant velocity or uniform velocity. Okay. So now here, let us consider this point as A, this point as B, this point as C. Actually, the area of VT graph represents displacement. So here we have to show that the area under velocity time graph gives displacement. Okay, so area of this graph, okay, that is area of what? O A B C. Area of O A B C. The area enclosed by the graph, area enclosed by this graph, that is area of OABC, that is equal to so actually this is looking like a rectangle, right? Area of the rectangle is length into breadth. That means OA, that is the length, right? OA into OC. So what is the value of OA? OA is 2 meter per second, right? OA is 2 meter per second, and OC, that is 4 second. Second get cancels. 4 into 2, what is that? 8 meter. Okay, meter, that is the unit of displacement. So this clearly shows that area enclosed by the VT graph. Okay, area of VT graph gives displacement. So this point is very, very important. So area of VT graph gives what? Displacement, right? So here, what is the value of slope? And this graph, the slope is, slope. What is the meaning of slope? Slope is the ratio of vertical distance divided by horizontal distance between 2 points on a straight line. Actually here A and B are 2 points on a straight line. So what is the vertical distance between point A and B? Vertical distance is 0. 0 divided by anything is 0. Okay. Actually slope of VT graph gives acceleration. But if a particle moving with a constant velocity, uniform velocity, its acceleration is equal to 0. If a particle moving with a constant velocity, its acceleration is 0. So this point is also very, very important. So if a particle moving with constant velocity, then its acceleration okay, acceleration is equal to 0. Okay, the next graph, a particle starting from rest and moving with uniform positive acceleration. A particle starting from rest and moving with uniform positive acceleration. Okay, again let us consider a velocity time graph. That means the velocity that is taken along y-axis and time that is taken along x-axis. What is the meaning of velocity time graph? A graph drawn by taking velocity that is along y-axis, time that is along x-axis. So velocity is measured in terms of meter per second. Time is measured in terms of second. So again, choose the same scale. That means in x-axis, 1 unit is 1 second. This is 1. What is this? 2, 3, 4, and so on. And in y-axis, 1 unit is 1 meter per second. This is 1, 2, 3, 4, and so on. Okay, a particle starting from rest. That means the initial velocity. Let us consider V naught. V naught is the initial velocity of the particle at time t is equal to 0. At time t is equal to 0, the initial velocity of the particle is equal to 0. So the first point is 0, 0. Okay, and then at time t is equal to 1 second, the particle velocity changes by 1 meter per second. Okay, its velocity increased by 1 meter per second. Then the next point is 1 comma 1. So this is 1 comma 1. So after 1 second, at time t is equal to 2 second, its velocity further increased by 1 meter per second. So that is actually 2 meter per second. At time t is equal to 2 second, the velocity of the particle is 2 meter per second. So the point is 2 comma 2. Okay. So after 1 second, its velocity further increased by 1 meter per second. So the final velocity is 3 meter per second at time t is equal to 3 seconds. So what is the point here? That is 3 comma 3. Okay. So the next 1 second, its velocity becomes 4 meter per second. So the point in the graph, that is 4 comma 4. So now we can join all these points. Okay, now we get a straight line that is passing through the origin. Okay, so this graph clearly shows that a particle starting from rest, okay, particle starting from rest, that means at time t is equal to 0, the initial velocity of the particle, that is equal to 0. So after that, its velocity changes. Its velocity changes by equal amounts, that is in equal intervals of time. Okay, so here particle starting from rest, after that its velocity, particle velocity changes. Particle velocity changes by equal amounts, that is in equal intervals of time. That means the particle is moving with uniform positive acceleration. Okay, so here let us consider the two observation points. It is point A and point B. So these 2 points are lies on a straight line. Okay, so here we have to find out the slope. What is the meaning of slope? Slope is the ratio of vertical distance divided by horizontal distance between 2 points on a straight line. This is the horizontal distance between A and B. This is the vertical distance between A and B. Okay, let us consider this point as C. So here the slope is the ratio of vertical distance, that is BC, divided by horizontal distance, that is AC. So the point B corresponding velocity, so this is the final velocity. So the final velocity of the particle is 4 meter per second. So the point A corresponding velocity, that is the initial velocity, let us consider that is V1. V1 is equal to 2 meter per second. The point A corresponding time is the initial time, that is 2 seconds. The point B corresponding time is the final time, that is 4 seconds. So BC is V2 minus V1. Okay. AC is T2 minus T1. So V2 minus V1. V2 minus V1 is 4 minus 2. So this is in terms of meter per second, and T2 minus T1. That means 4 minus 2, 4 minus 2 second. Okay, so this is 4 minus 2 is 2 meter per second divided by 4 minus 2, that is 2 second. 2 get cancels here. So this is 1 meter per second square. So this clearly shows that the slope of VT graph gives acceleration. Okay, and this acceleration is constant here. Okay, so here slope is constant. Slope is constant. That means acceleration is constant. Okay, acceleration is constant and positive. Okay, slope is constant and positive. That means acceleration is constant and positive. Okay, so this graph clearly shows that a particle starting from rest, a particle starting from rest and moving with uniform positive acceleration. So this graph shows a particle moving with uniform velocity. Okay, a particle moving with uniform velocity, its acceleration is zero. But here, particle moving with uniform positive acceleration. That means the velocity of particle changes by equal amounts, that is in equal intervals of time. So here, acceleration is constant, but that is positive. Okay, let's go to the next graph. A particle starting from rest and moving with uniform positive acceleration. Actually, here a particle starting with initial velocity. Okay, particle starting with initial velocity and moving with uniform positive acceleration. Particle starting, a particle starting with initial velocity. Particle starting with initial velocity and moving with uniform positive acceleration. Last graph is particle starting from rest and moving with uniform positive acceleration. So this is a particle starting with initial velocity. Starting from rest means straight line passing through the origin. Okay, but here the straight line that is not passing through the origin, because here particle starting with some initial velocity and moving with uniform positive acceleration. That means its velocity changes by equal amounts in equal intervals of time. Okay, so this is again VT graph, a graph drawn by taking velocity that is along y-axis. This is measured in terms of meter per second, and time that is taken along x-axis, and this is measured in terms of seconds. Okay, so this graph clearly shows a particle starting with some initial velocity. So V naught is the initial velocity of the particle. At time t is equal to 0, at time t is equal to 0, the velocity of the particle that is not equal to 0. So that is equal to V naught. V naught is called the initial velocity. Okay, this V naught is called what? The initial velocity. V naught is the initial velocity of the particle. Okay, so here particle starting with initial velocity. So after that, its velocity changes by equal amounts in equal intervals of time. So here again, the slope is positive, right? Positive and constant. Slope is positive and constant. Okay, next graph. A particle moving with increasing acceleration. Okay, particle moving with increasing acceleration means in VT graph we will get the rising curve. Is it not? So this is VT graph. The velocity is taken along y-axis, time is taken along x-axis. So here we will get the rising curve. That means the particle moving with increasing acceleration. So in this graph, slope is positive, and that is variable. Slope is positive and it is variable. Okay, actually here acceleration, that is, gradually increases. Okay, so this graph clearly shows that a particle that is moving with increasing acceleration. Okay, so the next graph, a particle moving with uniform negative acceleration. Okay, so a particle moving with uniform negative acceleration. Again, let us consider VT graph. Velocity is taken along y-axis, time is taken along x-axis. Okay, so this is origin. So here the velocity of particle changes by equal amounts in equal intervals of time, but that is gradually decreasing. So this is uniform negative acceleration. As the time increases, the velocity of particle decreases. The velocity of particle decreases by equal amounts in equal intervals of time. Okay, particle moving with uniform positive acceleration means as the time increases, the velocity of particle increases by equal amounts in equal intervals of time. Is it not? A particle moving with uniform positive acceleration means as the time increases, what happens? As the time increases, the velocity increases by equal amounts in equal intervals of time. But here, as the time increases, the velocity of particle decreases. The velocity of particle decreases by equal amounts in equal intervals of time. So here slope is positive. Sorry, here slope is not positive, slope is negative. Okay. So here actually the slope is negative and constant. Slope is negative and constant. Okay, a particle moving with uniform positive acceleration. Particle moving with uniform positive acceleration means so we will get the graph like this. Is it not? So this graph shows a particle moving with uniform positive acceleration. That means as the time increases, the velocity of particle changes by velocity of particle increases by equal amounts in equal intervals of time. But here, as the time increases, the velocity of particle decreases. Velocity of particle decreases by equal amounts in equal intervals of time. So in this graph, slope is positive and constant, but here the slope in this graph, slope is negative and constant. Okay. The next graph, that is a particle moving with decreasing acceleration. So here we will get the decreasing curve. In VT graph, we will get a decreasing curve. Again, let us consider VT graph. Velocity is taken along y-axis, time is taken along x-axis. Okay, so this curve shows as the time increases, the acceleration of particle that is gradually decreases. This graph shows a particle moving with decreasing acceleration. So here slope is negative. Here is also slope is negative. Here is also slope is negative, but it is not constant. Here the slope is variable. Okay, so this is about the velocity time graph. So the next concept, the conversion of velocity time graph to acceleration time graph. Conversion of velocity time graph to acceleration time graph. Acceleration time graph means a graph drawn by taking acceleration, that is along y-axis, time along x-axis. First here, let us consider VT graph. Okay, now look at this graph carefully. Okay, velocity is taken along y-axis. Okay, time is taken along x-axis. Okay, and here from O to A, what is the nature of motion of the particle? That is very important. So this graph is actually divided into three parts: O to A, and then A to B, after that B to C. Okay, in the time interval O to A, look at this graph carefully. In the time interval O to A, so what happens here? The particle velocity changes. Is it not? Particle velocity changes by equal amounts in equal intervals of time. That means here acceleration is constant and positive, right? From O to A, okay, particle velocity changes. How? Particle velocity changes by equal amounts in equal intervals of time. So here from O to A, acceleration is constant, acceleration is constant, and that is positive, right? Now in the time interval, that is from A to B. So what is the nature of motion of the particle? So here from A to B, particle actually moving with a constant velocity, uniform velocity, is it not? Because this is a straight line parallel to time axis, means as the time increases, velocity will remain constant. Okay, as the time increases from A to B, what happens to the velocity of the particle here? The velocity that will remain constant. So that will clearly shows that a particle moving with the constant velocity, particle moving with a constant velocity. Okay, so particle moving with constant velocity, what is its acceleration? That is very important, right? So acceleration is how much? Particle moving with constant velocity, its acceleration is equal to 0. Is it not? So after that, in the time interval, B to C, in the time interval B to C, in the time interval B to C. So what is the nature of motion of the particle? So actually here as the time increases, the velocity of particle changes. Velocity of particle decreases. Okay, velocity of particle decreases by equal amounts in equal intervals of time. So from O to A, particle velocity increases by equal amounts in equal intervals of time. That is uniform positive acceleration. From A to B, a particle moving with constant velocity. That means the acceleration is equal to 0. Okay, in the time interval B to C, the particle velocity decreases. Particle velocity decreases by equal amounts and equal intervals of time. So here, what is the acceleration? Acceleration is constant, right? Acceleration is constant, but that is not positive, negative. Here the slope is negative and constant. Okay. So now let us consider the AT graph. Okay, what is the meaning of AT graph? A graph drawn by taking acceleration along y-axis and time, that is along x-axis. Okay, so here the time, that is divided into 3 equal parts. So this is the origin, right? O to A to B, and B to C. So in the time interval O to A, so in VT graph, it clearly shows that acceleration is constant and positive. Okay, so now look at this graph from O to A. So acceleration that is constant and that is positive. Is it not? From O to A, acceleration here constant. So this is not VT graph, this is AT graph. This one is the VT graph, but the nature of motion of the particle is same. From O to A to B, B to C, the nature of motion of the particle is same. But the representation, that is different. Okay, from O to A, here acceleration is constant and that is positive. And in the time interval A to B, from A to B, actually particle moving with constant velocity. That means its acceleration is 0. Okay, its acceleration. So here from point A to point B, acceleration of the particle is how much? 0. Point A to point B, the acceleration of the particle, that is equal to 0. Okay. After that, in the time interval B to C, actually the particle is moving. Particle velocity decreases by equal amounts in equal intervals of time. That means the acceleration is constant. Now look at this graph. Acceleration is constant. Time increases, acceleration is constant, but that is not positive, it's negative. So here the acceleration is positive, but here the acceleration is negative. Okay, in the time interval B to C, particle velocity decreases by equal amounts in equal intervals of time. So that the acceleration is constant, but that is negative. Okay, the time interval B to C, the velocity of particle decreases by equal amounts in equal intervals of time. That means acceleration is constant. Acceleration from B to C, that is constant, but that is negative. Okay, that is negative. Here the acceleration is constant and positive. So here acceleration is constant, but that is negative. But from A to B, acceleration is equal to 0. So this is the conversion of velocity time graph to acceleration time graph. Okay. Okay. Thank you.